Welcome to the Dream Architect channel. Today we journey to our planet's silent companion, to a kingdom of silver dust and eternal peace. We will not fly on a rocket, but on the wings of imagination, to touch the secrets the moon has kept for billions of years. It is our eternal calendar, our nightly lantern, a mirror reflecting not only the sun's light, but also our deepest dreams. Its silence is not emptiness, but a chronicle of time, written in the language of craters and seas. If you enjoy these quiet journeys, I invite you to leave a like, subscribe, or share a thought below. It helps others find their way here, one sleepy soul at a time. And now, just breathe. Allow your eyes to grow heavy and your mind to soften. Let us begin. The moon is not merely a stone in the sky, but a silent silver ghost born from the single most violent event in our planet's history. The prevailing theory, a story of cosmic catastrophe known as the Giant Impact Hypothesis, tells of a time when our young Earth had a catastrophic encounter with another world. A rogue protoplanet, roughly the size of Mars and poetically named Theia, collided with our own. The impact was not a simple crash, but a glancing blow of unimaginable energy, vaporizing the intruder and blasting a colossal portion of Earth's own mantle into orbit. This cloud of incandescent rock and vapor, a fiery ring around our wounded world, became the crucible of a new creation. From this chaos of fire and destruction, a new and calmer beauty was destined to coalesce, a pearl of peace born from a planetary wound. This fiery birth left the moon entirely molten, a glowing orb enveloped in an ocean of magma hundreds of kilometers deep. For millions of years, this sphere of liquid rock slowly cooled, like a giant drop of metal solidifying in the vacuum of space. As the outer layers radiated their heat away, lighter minerals began to crystallize and float to the surface, a process called magmatic differentiation. This created a global ocean of molten rock, a shimmering, self-illuminated world with no solid ground, its only landscape the slow, viscous currents of its own substance. Beneath this thin, fragile skin, a hot heart still beat, full of geological promise and simmering power. From this cooling magma ocean, the moon's first crust began to form, composed of a light, pale rock called anorthosite. This feldspar-rich material, being less dense than the magma it floated upon, accumulated at the surface like a layer of cream, solidifying into the bright ancient highlands we see today. This process, which created the primordial lunar crust, happened remarkably quickly, perhaps in just a few million years. These highlands, or terrae, are the moon's original skin, a canvas of pale stone that would bear witness to all of its subsequent history. They are the oldest landscapes on the moon, a foundation of light upon which all other features would later be drawn. Once formed, this ancient lunar crust immediately began to record the history of a brutal era known as the Late Heavy Bombardment. The young solar system was a chaotic shooting gallery, and for hundreds of millions of years, the moon was pelted by a relentless storm of asteroids and comets. Each impact was an event of colossal energy, melting the surface and blasting out craters of all sizes, scarring the pristine white crust. The lunar surface became a canvas upon which cosmic chaos painted its violent masterpiece, a portrait that has remained almost unchanged ever since. These countless craters are not just holes. They are the frozen fingerprints of ancient violence, preserved perfectly in the airless void. Some of these ancient impacts were so gargantuan that they fractured the moon's thin, newly formed crust, creating vast, deep basins. For a time, these basins remained as immense, empty bowls, stark reminders of the violence of the moon's youth. But deep within the moon, the slow decay of radioactive elements kept the mantle hot and molten. This internal heat built up pressure over hundreds of millions of years, seeking release. The great scars on the surface provided the perfect conduits for this pent-up energy. This dark basaltic lava, the very blood of the moon's interior, was about to spill forth and reshape the world. This internal heat eventually caused dark basaltic lava to well up from the depths and flood onto the surface through the fissures created by the giant impacts. The dark, runny lava slowly filled the lowest-lying areas, the giant impact basins, creating smooth, dark plains. This process, known as lunar volcanism, was not explosive but effusive, with lava flowing gently for centuries to cover vast areas. The dark material is the solidified blood of the ancient moon, spilled from its interior to heal its deepest wounds and paint a new, darker face upon the old, pale one. These vast, dark plains were mistaken for seas by early astronomers like Galileo, who named them Maria, the Latin word for seas. Though we now know they contain no water, the poetic name has endured. The Sea of Tranquility, the Ocean of Storms, the Sea of Rains. Their names evoke a sense of peace and weather that does not exist on the airless moon. Their darkness is simply the color of the iron-rich basalt rock from which they are made, a stark contrast to the lighter highlands. These seas form the familiar patterns of the man in the moon, an eternal illusion of a face, etched in light and shadow. This process created the fundamental dichotomy of the lunar landscape: the ancient, heavily cratered, bright highlands, and the younger, smoother, dark Maria. This division is the key to reading the moon's entire history, visible even to the naked eye from Earth. The highlands, or terrae, are made of lighter anorthosite and hold the memories of the moon's earliest, most violent epochs. The Maria, composed of heavier basalt, tell a later story of volcanic activity and internal heat. This eternal dialogue between the old and the new, the light and the shadow, is the most fundamental feature of lunar geology, a story written in stone and darkness. The moon is locked in a silent, eternal gaze with our planet, always showing us the same face. This phenomenon, known as synchronous rotation or tidal lock, is the result of billions of years of gravitational conversation between Earth and Moon. Earth's immense gravity pulled on the moon when it was young and spinning faster, creating tidal bulges in its rock, just as the moon creates tides in our oceans. This gravitational friction acted as a brake, gradually slowing the moon's spin until its rotation period perfectly matched its orbital period around the Earth. Now, its day and its year are one and the same, the culmination of the most gentle and prolonged dance in the solar system. Because of this intimate dance, the far side of the moon remained a complete mystery to humanity until the dawn of the space age. Hidden from our view for all of history, it turned out to be strikingly different from the familiar near side. It has almost no large, dark Maria. Instead, the far side is a nearly unbroken expanse of ancient, pale highlands, battered and saturated with craters. The crust on the far side is significantly thicker, which likely prevented the basaltic magma from breaking through to the surface. This profound asymmetry is one of the moon's greatest puzzles, a quiet whisper that what we see is only half the story. This gravitational waltz has a reciprocal effect. The moon is slowly but inexorably moving away from the Earth. Each year, it drifts about 3-8 centimeters further out into space, roughly the same speed at which your fingernails grow. This happens because the moon, by creating tides on Earth, transfers rotational energy from our planet to itself. As Earth's spin slows down, the moon gains that energy and uses it to climb into a higher orbit. Billions of years ago, it was much closer, appearing monstrously large in the sky. One day, it will be but a distant point of light, and our descendants will see a very different night sky. The ebb and flow of our oceans are the most visible manifestation of the moon's gravitational embrace. It pulls on the Earth's waters, creating two tidal bulges on opposite sides of the planet. As the Earth rotates, its continents pass through these bulges of water, which we experience as high and low tides. This daily breath of the ocean, choreographed by the lunar rhythm, is a constant, tangible reminder of our profound connection to our satellite. The moon is literally pulling the strings of our world's oceans, conducting their eternal rhythmic motion from 250,000 miles away, a silent conductor for a planetary orchestra. But the moon's influence extends beyond the water. It also creates tides in the solid crust of the Earth. Twice each day, the very ground beneath your feet rises and falls by several tens of centimeters. We don't notice this subtle movement because everything around us, houses, trees, mountains, moves along with it. But sensitive scientific instruments can detect this breathing of the solid Earth. It is another testament to how deep and pervasive the connection is between our world and its companion. The Earth is not a rigid ball, but a living body that responds to the moon's gentle, rhythmic touch. This constant tidal breaking from the moon is gradually making Earth's days longer. Back in the time of the dinosaurs, a day on Earth lasted only about 23 hours. The gravitational friction created by the lunar tides acts as a brake on our planet's rotation. The effect is minuscule, adding about 1.7 milliseconds to the length of a day every century. But over geological time, it adds up to hours. The moon is stealing moments from our day, stretching them out, as if it is slowing down time itself. We live in an era where our 24-hour day is a direct consequence of this ancient cosmic mechanism, a gift of time from our silent partner. A total solar eclipse is a breathtaking cosmic coincidence, possible only because the moon is at the perfect distance from us right now. From our perspective on Earth, the moon's apparent size in the sky is almost exactly the same as the sun's. This allows it to perfectly block the sun's bright disk, or photosphere, while leaving the outer atmosphere visible. If it were closer, eclipses would be more common and longer, but they would hide the sun's corona. If it were much farther away, it would no longer be able to completely cover the sun's disk. We live in a brief, fleeting window of cosmic time when this perfect celestial ballet is possible. It is thanks to this precious gift that humanity first laid eyes on the solar corona, the sun's tenuous outer atmosphere, superheated to millions of degrees. Normally, its faint light is completely drowned out by the dazzling glare of the sun's main disk. But when the moon slides perfectly in front of the sun, a pearlescent, ethereal halo flashes into view around the black silhouette. The study of these eclipses has provided astronomers with invaluable information about the physics of our star. The moon, by blocking the light, paradoxically shed light on many of the sun's deepest secrets, a dark lens that revealed a hidden fire. The moon has no atmosphere in the way we understand it. What surrounds it is an incredibly thin layer of particles called an exosphere, with a density trillions of times less than the air we breathe. Here, gas molecules don't collide with each other but travel in long, arcing paths like tiny cannonballs, eventually either escaping into space or falling back to the surface. This near-perfect vacuum means there is no wind, no weather, and no sound. An absolute primordial silence reigns, broken only by the whisper-soft impact of micrometeorites. It is a world where silence is a tangible presence, a physical quality of the landscape itself. Because of this lack of atmosphere, the lunar sky is always black, even in the middle of the day. The sun is a blindingly brilliant disk set against a backdrop of velvet black, studded with the sharp, unblinking lights of the stars and distant galaxies. There is no blue haze to scatter the light, no clouds to drift by, no sunrises or sunsets to paint the sky with color. The transition from day to night is instantaneous, like flipping a switch. Standing on the moon, one could see both the searing sun and the faint Andromeda galaxy in the same sky, a vision of absolute and stark contrast, of fire and void in the same glance. The absence of an atmospheric blanket also means that temperatures on the lunar surface swing to brutal extremes. In the equatorial regions during the long lunar day, which lasts for 2 Earth weeks, the surface can heat up to a scorching 127 degrees Celsius, well above the boiling point of water. But as soon as the sun sets, with no air to trap the heat, it radiates away into space instantly. The temperature then plummets to a cryogenic minus 173 degrees Celsius during the 2-week night. This savage cycle of fire and ice makes the lunar surface one of the most inhospitable environments in the solar system. Yet, the coldest known places in the entire solar system are not on distant Pluto, but hidden on our nearby moon. They are found at the bottom of craters near the lunar poles, areas that are permanently shielded from the sun's rays. The floors of these permanently shadowed regions have not seen sunlight for billions of years, making them cosmic cold traps. Temperatures there can drop as low as -248 degrees Celsius, just 25 degrees above absolute zero, the theoretical point of no heat at all. These craters are perfect natural freezers, capable of preserving volatile compounds for eons in a state of absolute stillness. It is within these eternally dark and frigid craters that scientists have found definitive proof of water ice. Missions like India's Chandrayaan-1 and NASA's Lunar Reconnaissance Orbiter, LRO, confirmed that deposits of ice, mixed with lunar soil, exist at the bottom of these polar craters. This water was likely delivered to the moon over billions of years by impacting comets and asteroids, and it has remained preserved in the icy grip of perpetual darkness. This discovery completely transformed our view of the moon from a bone-dry world to a repository of the most valuable resource for life and future exploration, a hidden oasis in a silver desert. The entire surface of the moon is covered by a fine, flour-like dust called regolith. This is not soil in the earthly sense, as it contains no organic matter. Instead, it is the product of billions of years of micrometeoroid impacts shattering and pulverizing the lunar rocks. The individual particles of regolith are tiny, sharp, and abrasive, like microscopic shards of glass, their edges never smoothed by wind or water. This dust gets everywhere, clogging mechanisms and posing a health risk to astronauts. It is the moon's memory, a powdered archive of every impact it has ever endured. After being brought into the lunar module, this dust gave off a distinct and unforgettable odor, described by Apollo astronaut Harrison Schmitt as smelling like spent gunpowder. This smell was not inherent to the dust itself, but was the result of a chemical reaction. The lunar dust, having been in a vacuum for eons, had reactive, dangling chemical bonds on its surface. When it came into contact with the moist, oxygen-rich air inside the module, these bonds reacted, creating the sharp, metallic odor. It was the smell of the moon itself, finally breathing air for the first time. This lunar dust possesses a strange and ghostly property. It levitates. Around sunrise and sunset, observers have noted a faint glow and hazy streamers extending high above the lunar horizon. This is believed to be a dust atmosphere, caused by fine particles being lifted and suspended above the surface. During the day, solar ultraviolet radiation can knock electrons off dust grains, giving them a positive electrical charge. They then repel each other and the similarly charged surface, floating upwards in the weak gravity. The moon literally breathes a fog of dust when light touches its horizon, creating a fleeting electrical dawn. Despite its outward silence, the moon is not geologically dead. It experiences moonquakes, which, unlike their brief and violent earthly counterparts, can last for hours. Seismometers left behind by the Apollo astronauts recorded thousands of these events. Some are deep quakes caused by the tidal stresses of Earth's gravity stretching and squeezing the moon. Others are shallow quakes caused by the continued cooling and shrinking of its interior. These faint but incredibly long tremors tell us that the moon's heart is not yet cold, and that it rings like a bell for a very long time after each shudder. Unlike the Earth, the moon has no global magnetic field to protect it. Its small iron core has mostly cooled and solidified, shutting down the internal dynamo machine that generates such a field. This leaves its surface exposed to the full force of the solar wind and cosmic radiation. Any life on the lunar surface would be subjected to a constant barrage of high-energy particles, making the lack of a magnetic shield one of the greatest challenges to long-term human habitation. The moon is a world without a protective aura, naked to the energies of the cosmos. However, scientists were surprised to find that samples of lunar crust brought back by Apollo astronauts were magnetized. This suggests that in the distant past, around 3 to 4 billion years ago, the moon had its own powerful magnetic field, perhaps even stronger than Earth's is today. Then, For reasons not fully understood, the dynamo stopped. The moon lost its shield, but the memory of it remains locked within its oldest rocks. These magnetized stones are fossil records of a lost power, echoes of a time when the moon had a vibrant, protective heart. The solar wind, a constant stream of charged particles flowing from the sun, bombards the lunar surface unimpeded. Over billions of years, it has embedded vast quantities of elements from the sun into the top layer of the regolith. Among these is helium-3, a rare isotope on Earth that is considered a potential fuel for future nuclear fusion reactors, a clean and incredibly powerful source of energy. The lunar regolith is, in essence, a vast collector of solar material, accumulated over eons. The moon could one day become the key to humanity's energy future, its soil a treasure trove of captured sunlight. The mountains of the moon are nothing like the mountains of Earth. They were not formed by the slow collision of tectonic plates, like the Himalayas or the Alps. Instead, most major lunar mountain ranges are actually the raised rims of giant, ancient impact basins. The Montes Apenninus, for example, which tower up to 5 kilometers high, form the southeastern edge of the immense Imbrium Basin, or Sea of Rains. They were violently uplifted and thrown into place by the cataclysmic impact of an asteroid billions of years ago. They are not mountains of growth, but frozen waves from a stone thrown into a cosmic pond. The highest point on the moon is on its hidden far side and is significantly taller than Mount Everest. This peak, located on the rim of the Engelgart crater, rises nearly 11 kilometers above the moon's average surface level. At the same time, the lowest point, the floor of the Antoniadi crater, also on the far side, lies more than 9 kilometers below the average level. This means the total range of elevation on the moon is actually greater than on Earth. Its hidden face holds landscapes of truly epic and dramatic scale, far grander than anything on the side we see, a testament to a history more violent than our own. On the surface of the lunar Maria, there are unique geological features called wrinkle ridges. These are long, sinuous, and low-lying ridges that snake across the dark plains, like veins on the back of a hand or wrinkles in a rug. They formed as the vast sheets of basaltic lava that filled the impact basins cooled, contracted, and subsided under their own immense weight. The solid crust on top was compressed and buckled, forming these distinctive folds. These ridges are the fossilized evidence of the final convulsions of the cooling lava seas, the last sighs of a dying volcanism. Other mysterious channels that crisscross the lunar surface are known as rilles. These come in 3 main types: sinuous, arcuate, and linear. Sinuous rilles, like the spectacular Valles Schroetteri, are winding channels that are most likely collapsed lava tubes, ancient subterranean tunnels through which molten rock once flowed beneath the surface. Arcuate and linear rilles, on the other hand, are graben, sections of crust that have dropped down between 2 parallel faults. These giant cracks and channels are scars on the moon's face, telling a story of its turbulent volcanic and tectonic past. Some of these ancient lava tubes did not collapse and remain intact today as vast, empty caverns beneath the lunar surface. Planetary scientists have identified several skylights, deep pits that are likely openings into these huge subterranean caves, which could be kilometers wide. These tunnels could provide ideal locations for future human bases, offering natural and effective protection from the harsh radiation, micrometeoroid impacts, and extreme temperatures on the surface. Humanity's future home on the moon might not be on it, but within it, sheltered inside the hollow arteries of its ancient volcanic heart. The force of gravity on the moon is only 1/6 of that on Earth. This means you would weigh 6 times less, and you could jump 6 times higher and farther. Walking on the moon, as described by the Apollo astronauts, is a slow-motion ballet, a combination of skipping and floating. Each step becomes a gentle, soaring leap. This feeling of lightness and effortless flight is one of the most profound physical sensations a human can experience, a true liberation from the familiar shackles of Earth's gravity. It is the physical sensation of freedom, of being untethered from your home world. Because of this weak gravity and the total absence of air resistance, all objects on the moon fall at the same rate, regardless of their mass or shape. Apollo 15 Commander David Scott beautifully demonstrated this fundamental principle of physics. He stood before the camera and dropped a geological hammer and a falcon feather at the same time. On Earth, the feather would have fluttered slowly down, held back by the air. But on the moon, in the perfect vacuum, the hammer and the feather fell in perfect unison, striking the gray dust at the exact same instant. It was a simple, elegant experiment that spoke volumes about the purity of physics in a world without atmosphere. The moon appears colorless to our eyes, a world of black, white, and shades of gray. However, when its surface is analyzed with sensitive spectrometers, it reveals a palette of subtle, hidden colors that tell the story of its chemistry. Areas rich in the mineral ilmenite, which contains titanium, have a faint bluish tint. Regions with higher concentrations of iron and glass from volcanic eruptions have a slightly reddish hue. Our moon is not a monochrome world, but a canvas of subdued and delicate shades, a mineralogical map painted in colors too faint for our eyes to see from afar, a secret beauty reserved for the instruments of science. The moon's diameter is about 3,474 kilometers, making it the fifth largest satellite in the solar system. However, relative to the size of its parent planet, the moon is exceptionally large. Its diameter is more than a quarter of Earth's. No other major moon is such a large fraction of its host planet's size. Because of this, the Earth-Moon system is often described by astronomers as a double planet, rather than a planet and a satellite. We are not a master and a servant, but true partners locked in a gravitational embrace, circling a common point in space together. Despite its brilliant appearance in our night sky, the moon is actually very dark. Its surface has a very low reflectivity, or albedo. On average, it reflects only about 12% of the sunlight that strikes it, which is comparable to the reflectivity of worn asphalt or a lump of coal. The moon only seems so bright to us because it is set against the pitch-black canvas of the night sky, and because our eyes are so well adapted to the darkness. If you could see the moon next to you in broad daylight on Earth, it would appear as a dark, charcoal gray rock. Its silver light is an illusion, a trick of contrast born from the surrounding darkness. A single lunar day, the time from one sunrise to the next at any given point on the surface, lasts for about 29.5 Earth days. This means that any spot on the moon experiences roughly 2 weeks of continuous, searing daylight, followed by 2 weeks of continuous, frigid night. This incredibly slow cycle of light and dark is profoundly different from the brisk 24-hour rhythm we are accustomed to on Earth. To live on the moon would mean adapting to this unhurried breath of light and shadow, to the long, slow dawn and the equally long wait for sunrise in the deep, abyssal cold. Even during the 2-week lunar night, the landscape is not plunged into absolute blackness. During this time, an observer on the moon would see a full Earth hanging in the sky. Our blue and white planet, in its full phase, shines with a light more than 50 times brighter than that of our full moon. This ethereal, bluish glow, reflected from Earth's clouds and oceans, gently illuminates the lunar nightscape. This is the phenomenon we call Earthshine, which we can see from Earth as a faint light on the dark portion of a crescent moon. Our planet serves as a beautiful, ghostly nightlight for its satellite. For an observer on the moon, the Earth does not rise or set. Because the moon is tidally locked, our planet hangs almost motionless in the black sky, only appearing to wobble slightly due to libration. For anyone on the near side of the moon, the Earth would be a constant, majestic presence above the horizon, cycling through its phases from a brilliant full disk to a slender crescent of blue and white. And for anyone on the far side, the Earth would never be seen at all. That lonely landscape is the only place in our cosmic neighborhood from which home is forever invisible. The moon plays a crucial role as our planet's cosmic anchor, stabilizing the tilt of Earth's axis. Our axis is tilted by about 5 degrees relative to our orbit around the sun, and it is this tilt that gives us the seasons. Without the moon's steadying gravitational influence, this tilt would wobble chaotically over millions of years, varying anywhere from 0 to 85 degrees. This would lead to catastrophic climate swings, with the equator freezing over and the poles melting. The moon provides the climatic stability that has allowed complex life to evolve and thrive on our world. The moon's core is surprisingly small, making up only about 1 to 2% of its total mass. This is in stark contrast to Earth, whose core accounts for about 30% of its mass. The lunar core consists of a solid inner sphere of iron, surrounded by a shell of molten iron. This diminutive core is another consequence of the moon's violent birth in the giant impact. Most of the heavy elements, like iron, from the colliding bodies ended up in the newly reformed Earth. The moon, formed from the lighter mantle material, received only a small fraction of its parent planet's iron heart. Though it appears as a perfect circle in our sky, the moon is actually shaped more like a slightly squashed lemon or an egg. Its shape is not a perfect sphere. The end that faces Earth is slightly elongated, pulled outwards by our planet's persistent gravity. This asymmetry is invisible to the naked eye, but is fundamental to the dynamics of the Earth-Moon system. The moon's center of mass is offset from its geometric center by about 2 kilometers, shifted ever so slightly towards the Earth. It is not a perfect orb, but a body forever deformed by the love of its gravitational partner. Across the lunar surface, there are mysterious, bright, swirling patterns that look like pale brushstrokes of milky paint. These lunar swirls are some of the moon's most enigmatic features, as they don't correspond to any craters or hills. They often coincide with areas of localized magnetic anomalies, fossilized pockets of the moon's ancient magnetic field, trapped in the crustal rock. One leading theory suggests that these small magnetic fields act as miniature shields, deflecting the solar wind. The surface underneath is protected from space weathering, so it darkens more slowly than the surrounding areas, creating these beautiful, ghostly patterns. The very first man-made object to reach the moon was the Soviet Union's Luna 2 probe in 1959. It did not perform a soft landing but was designed to impact the surface, which it did in the region of the Sea of Rains. On board, it carried pennants bearing the coat of arms of the USSR. This small metallic sphere, traveling from another world, marked the beginning of humanity's physical reach into the cosmos. It was the first human-made mark on the moon's ancient face, a silent announcement that a curious species had begun its journey outwards. The first ever photographs of the moon's mysterious far side were taken by another Soviet probe, Luna 3, later in that same pivotal year of 1959. The images were grainy and of low quality, transmitted slowly back to a waiting Earth. But they were revolutionary. For the first time, humanity peered behind the veil, seeing the hemisphere hidden for all of history. The pictures revealed a stark, rugged world, almost devoid of the dark Maria so common on the near side. This discovery raised more questions than it answered, forcing scientists to rethink their theories of the moon's evolution. The first successful soft landing on the moon was achieved by the Soviet Luna 9 probe in 1966. After a harrowing descent cushioned by airbags, the small lander came to rest in the ocean of storms and began to transmit the first-ever panoramic images taken from the lunar surface. The world saw a desolate, rock-strewn desert under a black sky. These stark images finally dispelled any lingering romantic fantasies of lunar inhabitants or verdant landscapes, revealing our satellite for what it was, a world of magnificent, cold, and lifeless beauty. The dream of the moon gave way to the reality of it. The first living beings to travel around the moon and return safely to Earth were not humans. They were 2 Central Asian tortoises, who were passengers aboard the Soviet Zond 5 spacecraft in 1968. Accompanied by wine flies, mealworms, and various plants and seeds, they looped around the far side of the moon and splashed down in the Indian Ocean. This mission was a crucial biological precursor to human flight, proving that complex organisms could survive the journey through deep space and the radiation belts around Earth. These humble tortoises were the first Earthlings to witness an Earthrise from behind the moon. The first human to walk on the surface of the moon was American astronaut Neil Armstrong on July 20th, 1969. His immortal words, "That's one small step for a man, one giant leap for mankind," echoed back to a captivated world. This singular moment, broadcast live to hundreds of millions of people, represented the culmination of a decade of effort and the realization of a dream as old as humanity itself. For the first time in history, a sentient being from planet Earth left its footprint on the soil of another world, an act of exploration that forever changed our perspective of our place in the universe. In total, only 12 people have ever walked on the moon. All were American astronauts, part of the Apollo program, and their missions took place in a brief, intense period between 1969 and 1972. The last person to leave his footprints on the lunar surface was Eugene Cernan, commander of Apollo 17, in December 1972. Since he climbed the ladder of his lunar module for the final time, no human has returned. For more than half a century, the moon has been a place of human memory, but not of human presence. Those 12 names remain etched in history as the first explorers of a new frontier. The footprints left by the Apollo astronauts in the lunar dust will remain there for millions of years. Because there is no wind to blow them away and no rain to wash them clean, the imprints of their boots, the tracks of the lunar rovers, and the discarded equipment will be preserved almost perfectly in the vacuum. The only forces that could erase them are the slow, steady rain of micrometeorites or a direct strike from a larger object. These silent tracks are a durable and poignant testament to our brief visit, a message to the future frozen in time and dust. The Apollo astronauts left behind more than just scientific instruments and footprints. They also left a collection of deeply personal and symbolic items. These include American flags, memorial plaques, and a photograph of astronaut Charlie Duke's family wrapped in plastic on the ground. These artifacts transform the landing sites into humanity's first off-world historical monuments. The moon became not just a scientific laboratory, but a quiet pantheon of our highest aspirations and our most profound losses, a museum under a silent, black sky. Among these items is a small aluminum sculpture called the Fallen Astronaut, left by the crew of Apollo 15. It is a stylized figure of an astronaut in a spacesuit, accompanied by a plaque listing the names of 14 American and Soviet space explorers who had died in the pursuit of spaceflight. Placed discreetly in the lunar dust, it is the only piece of art on the moon created solely for artistic purposes. It serves as a solemn and universal tribute, a quiet memorial on another world to the cost of reaching for the stars. Across the 6 Apollo landings, astronauts brought back a total of 382 kilograms of lunar rocks and soil. These samples, some of which are over 4.5 billion years old, are a scientific treasure beyond price. They have allowed us to look back into the earliest moments of the solar system's history, to confirm the giant impact theory of the moon's formation, and to piece together its complex geological evolution. These gray, unassuming stones turned out to be the Rosetta Stone for understanding our own origins, a physical link to the time of creation. Within these rock samples, geologists discovered a mineral that had never before been seen in nature on Earth. It was named armalcolite, a tribute to the 3 astronauts of the Apollo 11 mission, Armstrong, Aldrin, and Collins. Though this mineral was later found in certain locations on Earth, its initial discovery was there, in the Sea of Tranquility. It stands as another quiet reminder that the moon is a distinct world, with its own unique chemistry and history written in its very stones, a secret it revealed only when we came to visit. One of the most surprising and human moments on the moon was a game of golf. Alan Shepard, the commander of Apollo 14, had smuggled the head of a 6-iron and 2 golf balls aboard the spacecraft. Attaching the club head to a sample collection tool, he took 2 swings on the lunar surface. In the 1/6 gravity and with no air resistance, he famously exclaimed that the second ball traveled for miles and miles and miles. This playful, almost frivolous act became a powerful symbol of the human spirit, which finds room for joy and play even in the most alien and unforgiving of environments. The lunar roving vehicles, or LRVs, left behind by the last 3 Apollo missions are the most expensive abandoned cars in history. These remarkable electric vehicles allowed the astronauts to venture much farther from their landing modules, dramatically increasing the scientific return of their missions. They explored kilometers of terrain, climbing hills and navigating crater fields. Today, they sit silently on the surface, covered in a fine layer of dust, monuments to human ingenuity and our first attempts to drive on another world, waiting for a driver who may never return. The astronauts also deployed sets of retro reflectors on the lunar surface, which are still in use today. By firing powerful laser beams from Earth at these arrays of corner cube mirrors, scientists can measure the time it takes for the light to travel to the moon and back with millimeter precision. These ongoing lunar laser ranging experiments are what allow us to track the moon's slow recession from Earth so accurately. They also provide stringent tests of Einstein's theory of general relativity and help us study the moon's deep interior, turning the entire Earth-Moon system into a giant physics laboratory. The moon does not produce its own light. It shines only by reflecting the light of the sun. The phases of the moon that we observe are simply the result of our changing viewing angle of the moon's illuminated half as it orbits the Earth. The new moon, first quarter, full moon, and last quarter are not changes in the moon itself, but changes in our perspective. They are the visible manifestation of the celestial geometry of the sun, Earth, and moon. A grand, silent clock in the sky that has measured our months for millennia. A rhythm woven into the fabric of our culture and biology. The term blue moon doesn't mean the moon actually turns blue. It's a name given to the second full moon that occurs within a single calendar month, a relatively rare event that happens every 2 to 3 years. The phrase "once in a blue moon" has become a common idiom for something that happens very infrequently. It is simply a poetic name for a quirk in the celestial schedule, a reminder that even in the clockwork precision of the cosmos, there is room for occasional anomalies and unexpected gifts of light. On very rare occasions, the moon can actually appear to have a blue or even greenish tint when viewed from Earth. This strange coloration is not a property of the moon itself, but an effect of our own atmosphere. When large amounts of dust or ash particles of a specific size are suspended in the air, such as after a major volcanic eruption or a large forest fire, they scatter red light more effectively. This allows more of the blue and green parts of the spectrum to pass through to our eyes, tinting the moon's image. The color is a filter, painted by the Earth's air, a temporary mood of our own planet projected onto its companion. A blood moon is the dramatic name given to the moon during a total lunar eclipse. This happens when the Earth passes directly between the sun and the moon, casting its shadow over its satellite. The moon does not disappear completely, however. The Earth's atmosphere acts like a lens, refracting sunlight and bending it into the shadow. As it does so, it scatters away most of the blue light, allowing only the long red wavelengths to pass through. The moon is then bathed in the filtered light of all the sunrises and sunsets occurring on Earth at that moment, giving it a ghostly, coppery red glow. The harvest moon and hunter's moon are traditional names for the full moons that occur closest to the autumnal equinox. Around this time of year, the angle of the moon's path relative to the horizon is very shallow. This means that for several evenings in a row, the full or nearly full moon rises at almost the same time, soon after sunset. This provided farmers with extra hours of bright moonlight to bring in their crops, and hunters with light to track their game. The moon was not just a celestial ornament, but a practical and vital lamp for human activity. The moon illusion is a powerful optical trick that makes the moon appear much larger when it is near the horizon than when it is high in the sky. In reality, its angular size remains almost exactly the same. Scientists still debate the precise cause of this illusion, but it is a trick of our own minds, not a physical phenomenon. The most likely explanation is that our brain, seeing the moon next to familiar terrestrial objects like trees and buildings, interprets it as being farther away and thus physically larger than when it hangs alone in the vast, empty expanse of the zenith. The light from the moon takes approximately 1.3 seconds to reach our eyes on Earth. This means that when you look up at the moon, you are not seeing it as it is right now, but as it was just over a second ago. This tiny, almost imperceptible delay is our most immediate and personal encounter with the finite speed of light. Looking at the moon is, in the most literal sense, looking into the past. It is our closest window to the universe, and even it shows us only a reflection of a moment that has already gone, a ghost of light from a world just out of reach. The moon does not orbit the exact center of the Earth. In fact, both the Earth and the moon orbit around their common center of mass, a point known as the barycenter. Because the Earth is so much more massive, this point lies inside our planet, about 1,700 kilometers beneath the surface. This means the Earth doesn't sit still. It actually performs a small wobble as the moon circles it. Our planet is led on a leash by its companion, their dance more intricate and balanced than it first appears, a partnership of equals in motion. The word month is a direct descendant of the word moon. The lunar or synodic month, the cycle from one new moon to the next, is about 29.5 days long and formed the basis for humanity's very first calendars. Long before our ancestors tracked the yearly passage of the sun, they measured the flow of time by the reliable and easily observed phases of the moon. It was our first clock, its phases the first pages of a calendar written across the night sky for all to read, a measure of life's passing written in silver. The moon creates tides not only in our oceans but also in our atmosphere. The same gravitational pull that lifts the seas also creates vast, invisible waves in the ocean of air above us. These atmospheric tides cause small but measurable fluctuations in surface air pressure that follow the moon's position in the sky. We live at the bottom of an airy ocean that also breathes in and out in time with the lunar rhythm, a subtle effect we never feel, but which is happening all around us, all the time. The moon's influence is as pervasive as the air itself. Traces of surprisingly recent volcanic activity have been discovered on the moon, challenging the idea that it has been geologically dead for billions of years. Scientists have identified small, irregular patches of volcanic deposits that appear to be only 50 to 100 million years old. This suggests that pockets of magma may have erupted onto the surface as recently as the age of the dinosaurs on Earth. The moon's interior cooled much more slowly than we thought, and it may have remained alive and active for far longer than previously assumed, its last breaths of fire much more recent than we knew. The lunar regolith is rich in oxygen, but it is not free for breathing. It is chemically locked away inside silicate and metal oxide minerals, making up about 45% of the soil's mass. However, through a process called molten oxide electrolysis, it would be possible to heat the regolith and pass an electric current through it, breaking the chemical bonds and releasing the oxygen. This could be used for breathing air or as a component of rocket propellant. Future lunar colonists might literally be able to breathe the rocks beneath their feet, finding life in the very dust of a dead world. For centuries, astronomers have reported seeing strange, fleeting flashes, glows, or hazy patches on the lunar surface, known as transient lunar phenomena, TLPs. The nature of these events is still a mystery. They could be plumes of gas escaping from the moon's interior through deep cracks, the bright flashes of meteoroid impacts, or simply tricks of the light and Earth's atmosphere. Whatever their cause, they suggest that the moon is not as static and unchanging as it seems. It is a world that sometimes winks at us, sharing a secret we have yet to understand. The crater Tycho is one of the youngest and most prominent features on the moon's near side, visible to the naked eye as a bright spot in the southern highlands. It is only about 108 million years old, a mere infant in lunar terms. The impact that formed it blasted out a spectacular system of bright rays, streaks of ejected material that stretch for thousands of kilometers across the lunar surface, like spokes on a wheel. The brightness of these rays is a sign of their youth. They have not yet been darkened by space weathering. Tycho is a fresh scar, a reminder that the era of cosmic collisions is not entirely over. Unlike Earth with its dynamic surface, the Moon has no plate tectonics. Its crust is a single, solid, stagnant lid that does not move, break apart, or subduct. This is why the Moon has no large, linear mountain chains like the Andes, and why its surface has preserved a pristine record of impacts stretching back billions of years. The Moon is a geological museum, its exhibits perfectly preserved behind the glass of a vacuum, while Earth's surface is constantly recycling and remaking itself, erasing the records of its own deep past. The name Moon comes from an ancient Proto-Germanic word, which itself derives from a Proto-Indo-European root related to the verb to measure. This reflects the Moon's ancient role as a timekeeper for early human societies. In the Romance languages, its name, like the Latin luna, comes from a different root word meaning light or brightness. In its very names, humanity has encoded the Moon's two primary functions in our lives and in our sky. It is both our measure and our light, our clock and our lantern. The Moon doesn't keep perfectly still in our sky. It appears to wobble slightly back and forth. These oscillations are called librations, and they allow us to see a little bit around the Moon's edges over the course of its orbit. Due to libration in longitude, east-west, and latitude, north-south, we can, over time, observe not just 50%, but about 59% of the total lunar surface from Earth. The Moon seems to be coyly nodding and shaking its head, allowing us brief, tantalizing glimpses of its hidden terrain, never revealing its whole self at once. There is a fascinating hypothesis that the early Earth may have had more than one moon. Computer simulations of the giant impact suggest that the debris cloud could have coalesced into several smaller bodies, not just one large one. These smaller moons would have shared an orbit with our current moon for a time. Eventually, their unstable orbits would have caused them to either be ejected from the system or to slowly spiral in and collide with the larger moon. Such a slow-motion collision could even explain the thicker crust on the far side, a graveyard of a long-lost sibling. On the Moon, there are ancient, dead volcanoes, but they don't look like the steep cones we know on Earth. They are vast, gentle domes called shield volcanoes, formed by the eruption of very fluid, runny lava that spread out over large areas. The Aristarchus Plateau is a prime example of such a volcanic complex, a broad, elevated region crisscrossed by rilles. These quiet, sleeping giants are silent witnesses to a time when the Moon's interior was hot and restless, and when rivers of molten rock flowed freely across its surface, building new landforms. Scientists are planning to build a radio telescope on the far side of the Moon. This location is the most radio-quiet place in the inner solar system, as the bulk of the Moon itself would act as a massive shield, blocking all the incessant radio noise and interference from Earth. From this silent vantage point, a telescope could listen for the faintest whispers from the cosmos, signals from the dark ages after the Big Bang when the very first stars were just beginning to shine. The far side of the Moon could become our ultimate ear to the universe, a place of perfect listening. The Moon's crust is not uniform. It is dramatically thinner on the near side, averaging about 50 kilometers, while on the far side, it can be up to 100 kilometers thick. This profound asymmetry is likely the reason why so many large maria formed on the near side. The thinner crust made it easier for magma from the mantle to break through. Why the crust is so lopsided remains one of the fundamental puzzles of lunar science, possibly linked to the way it cooled or even the impact of a lost second moon, its mass added to one side like a patch. The magnificent rings of Saturn might be the ghost of a former moon. According to one leading theory, Saturn once had a large, icy moon that strayed too close to the giant planet. It crossed a boundary known as the Roche limit, and Saturn's immense tidal forces tore it apart. The shattered remnants of this unfortunate moon then spread out to form the spectacular ring system we see today. When we look at Saturn's rings, we may be seeing a cautionary tale, a beautiful memorial to a lost world destroyed by the gravitational embrace of its parent, a fate our own moon has avoided. The South Pole Aitken Basin, located on the moon's far side, is the largest, deepest, and oldest confirmed impact crater in the entire solar system. It is an enormous feature, stretching 20,500 kilometers in diameter and plunging more than 13 kilometers deep. The impact that created it was so stupendously powerful that it may have punched straight through the lunar crust, dredging up material from the upper mantle. Studying this basin is a top priority for future missions, as it offers a unique window into the moon's deep interior, a wound that never healed and now reveals the world beneath. The moon is covered in glass. This glass is not volcanic, but is created by the intense heat and pressure of meteorite impacts. The instantaneous energy of a strike melts the lunar soil, which then cools so rapidly in the vacuum that it doesn't have time to form crystals, solidifying instead as glass. This impact glass is found all over the moon in the form of tiny, colorful spheres, teardrops, and dumbbells scattered throughout the regolith. The lunar soil sparkles with these microscopic frozen explosions, a testament to its violent history. During the Apollo 17 mission, astronauts Harrison Schmitt and Eugene Cernan discovered a patch of startlingly bright orange soil. This turned out to be composed of tiny beads of volcanic glass, erupted from a fire fountain more than 3.5 billion years ago. The molten spray cooled and solidified in mid-air, raining down as a blanket of orange and black glass. This vibrant splash of color, hidden for eons in the gray landscape, was a breathtaking glimpse into the moon's fiery volcanic past, a pocket of ancient fire preserved in the dust. Although the moon is slowly moving away from us, it will never escape Earth's gravity entirely. According to calculations, its recession will eventually stop. This will happen in the far distant future, tens of billions of years from now, when Earth's rotation has slowed down so much that its day becomes equal in length to the moon's orbital period. At that point, the Earth and moon will be locked in a final, stable embrace, forever showing the same face to each other, their long dance finally slowing to a perfect, synchronized stillness. The moon is not Earth's only natural satellite in a sense. Our planet has several quasi-satellites, asteroids that orbit the sun in a path very similar to Earth's, causing them to remain in our general vicinity for long periods. One such object, named Kamo-o-Alewa, has a composition that suggests it might actually be a fragment of the moon itself, blasted off by a major impact long ago. It now follows the Earth like a small, loyal dog. Our sky is not as empty as it seems. We are accompanied by these small, ghostly companions, lost children of the moon. The lunar surface is electrostatically charged by the constant bombardment of solar wind and ultraviolet radiation. This charge is strong enough to cause the levitation of dust particles we spoke of earlier, creating a hazy atmosphere near the ground. It also poses a significant challenge for future explorers and their equipment. The charged dust particles cling tenaciously to everything: spacesuits, visors, and machinery, like static-charged styrofoam, causing abrasion and potentially shorting out electronics. The very dust of the moon has an electric life of its own. In 2019, the Israeli spacecraft Bereshit crashed while attempting to land on the moon. On board was a lunar library, a digital archive of human knowledge, as well as a small container filled with thousands of tardigrades. These microscopic invertebrates, also known as water bears, are famous for their ability to survive extreme conditions, including the vacuum of space. Now, these creatures are likely scattered across the crash site in a dehydrated, dormant state. It's possible that we have unintentionally delivered the first, albeit sleeping, form of Earth life to the moon. Although the moon lacks global tectonic activity, it is still shrinking. As its deep interior continues to slowly cool and lose heat, the entire moon is gradually contracting, decreasing in volume. This global compression causes the brittle crust to wrinkle and break, forming small young fault lines called lobate scarps. These features, which can be several kilometers long and tens of meters high, are like wrinkles on a drying apple. The presence of these fresh faults tells us that the moon is still geologically active today, albeit in a very subtle way. It is an old world, but it is not yet a dead one. The pull of gravity is not the same everywhere on the moon's surface. Due to the uneven distribution of mass in its crust and mantle, there are regions of anomalously high gravity. These areas, called mascons, short for mass concentrations, are mostly located beneath the large, circular maria. They are likely dense plugs of mantle material that were uplifted by the giant impacts that formed the basins. These invisible gravity hills can significantly perturb the orbits of spacecraft, pulling them down and causing them to eventually crash if their orbits are not corrected. The moon is full of unseen gravitational reefs. If our planet had no moon, our nights would be profoundly dark. Apart from the faint light of the stars and other planets, the sky would be a blanket of black. This would have dramatically altered the evolution of countless species on Earth. The behavior, hunting patterns, and navigation of many nocturnal animals are deeply dependent on the cycles of moonlight. The moon is the silent shepherd of the night, its gentle light a guiding thread for a world of creatures that live in the dark, a pulse of light that has shaped life for millions of years. Some scientists have proposed a fascinating idea, that the moon could have acted as a transfer station for life in the early solar system. If a large asteroid struck an early Earth that already harbored primitive microbes, the impact could have blasted rocks containing those microbes into space. Some of these life-bearing rocks could have landed on the moon, where the microbes might have been preserved in a dormant state in the cold vacuum. A later impact on the moon could then have sent these rocks back to Earth. The moon could have been a temporary ark for the seeds of life. The first map of the moon was drawn by the English astronomer Thomas Harriot in 1609, a few months before Galileo's more famous observations. Using a telescope of his own design, he sketched the terminator line and noted the rough, cratered texture of the surface. However, Harriot never published his work, and his groundbreaking drawings remained unknown for centuries. It was a silent discovery, a secret understanding of a new world that he kept to himself. The first human to see the moon as a place, not just a light. It was Galileo Galilei who, later in 1609, first not only drew the moon as seen through a telescope, but also published and described his findings in detail in his work, Sidereus Nuncius. He showed the world that the moon was not a perfect ethereal sphere as the ancients believed, but a rugged physical world with mountains and plains, much like Earth. By calculating the length of shadows, he even estimated the height of the lunar mountains. This was a revolutionary blow to the old cosmology, bringing the heavens down to Earth. The names of the moon's features have been given over centuries according to various traditions. The Maria were given poetic and emotional names by early astronomers, such as the Sea of Tranquility, the Ocean of Storms, and the Sea of Crises. Later, the 17th century astronomer Giovanni Riccioli established the tradition of naming craters after great scientists, mathematicians, and philosophers. The map of the moon is thus a kind of hall of fame for human thought, its geography a tribute to the minds that sought to understand it. The moon is under constant silent assault from a shower of micrometeoroids, most no larger than a grain of sand. Every day, several tons of this material rain down on the surface. With no atmosphere to burn them up, they strike the ground at cosmic velocities, blasting out microscopic craters and slowly churning the top layer of soil. This process, known as space weathering, is what creates the regolith and slowly darkens the lunar surface over time. To stand on the moon would be to stand in a perpetual, invisible, and silent cosmic hailstorm. The lunar soil is utterly devoid of native organic compounds. The samples returned to Earth by the Apollo missions were found to be completely sterile, containing no evidence of past or present life. Billions of years of exposure to the harsh, unfiltered ultraviolet radiation from the sun and high-energy cosmic rays would have destroyed any complex organic molecules on the surface. The moon is a pristine reference point for non-biological matter, a clean slate where we can study geology and chemistry in their purest, most primordial form, untouched by the complexities of life. The last human to stand on the moon was Eugene Cernan. Just before he climbed the ladder of the Apollo 17 lunar module for the last time, he knelt and traced the initials of his young daughter, TDC, into the lunar dust. Because there is no erosion on the moon, those 3 letters are likely still there today, undisturbed on the edge of the Taurus-Littrow Valley. It was a final, deeply personal and touching gesture from humanity's last emissary to another world. A farewell letter written in the dust of ages. A father's love left on another world. The light of the moon, which we perceive as cool and silvery, is simply reflected sunlight, which is actually yellowish-white. The illusion of a silver color is created by our own eyes. In low-light conditions, our vision is dominated by the rod cells in our retina, which are highly sensitive to light but do not perceive color well. This scotopic vision renders the world in shades of gray. The moon's silver gleam is a phantom of our own biology, a color painted by the limitations of our night vision, a trick of the mind that has become a poetic truth. The distance to the moon is not constant. Its orbit around the Earth is an ellipse, not a perfect circle. The point in its orbit where it is closest to Earth is called perigee, and the farthest point is apogee. When a full moon coincides with its perigee, we experience a supermoon. On these occasions, the moon can appear up to 14% larger and 30% brighter than when it is at its farthest point. This is merely a line-of-sight effect, but it is a beautiful reminder that even the most regular celestial cycles have their own gentle ebb and flow. Future lunar missions are exploring the use of 3D printing to construct habitats and infrastructure. The ink for these printers would be the lunar regolith itself. Specialized rovers, equipped with microwaves or lasers, would sinter or melt the lunar dust, building up structures layer by layer. This would eliminate the need to transport heavy and bulky construction materials all the way from Earth, allowing us to live off the land. Humanity will build its new home from the very ground upon which it stands, using the dust of eons as its brick and mortar. The moon is not just a satellite. It is an inseparable part of our world. Its lost child, its faithful dance partner, its mirror, and its anchor. Its history is inextricably linked with ours. Its gravity shapes our planet's rhythms, and its light has inspired our souls for as long as we have looked to the sky. It is the silent keeper of the solar system's oldest secrets and the sole witness to our own brief and recent existence, a constant presence in our journey through the cosmos. Its silence is not emptiness, but fullness. The fullness of time, frozen in craters. The fullness of space, reflected in its dust. The fullness of the peace it offers our night sky. And as you drift into sleep, know that high above, this silver sphere continues its eternal silent path, guarding the dreams of our planet. If you enjoy these quiet journeys, I invite you to leave a like, subscribe, or share a thought below. It helps others find their way here, one sleepy soul at a time. And now, just breathe. Let your eyes grow heavy, and let the quiet lunar seas cradle your thoughts. Good night.